This is lesson 6.1. We're going to talk about perpendicular and angle bisectors. So first we'll define a perpendicular bisector, and it's really the two parts of the word. It's perpendicular to a segment at the midpoint of the segment, and that's where the bisector comes in. So it is at a right angle with the segment, and it splits that segment in half. Other things happen when a line is a perpendicular bisector. So the perpendicular bisector theorem says any point that's on the perpendicular bisector is equidistant from the endpoints of that segment. So if CD is the perpendicular bisector, that means C is on it, and C would then be the same distance from A as it is from B. And the reverse is also true. Oh, don't know how that happened. The reverse is also true. If I know that a point happens to be equidistant from the endpoints of a segment, we could say that point is on the perpendicular bisector. We don't necessarily know that this line itself, actually, I'm looking at this now, that this line itself would be the perpendicular bisector, just that C is on it. So for example, 1A, we see that we have a perpendicular bisector by the right angle and the congruent segments, which is what's going to make these two segments equal to each other. So that's all we can do in this section is set segments equal. So I have 7x plus 24 is equal to 13x minus 48. If I take away 7x from both sides, I now have 24 equals 6x minus 48. If I add 48 to both sides, I now have 72 equals 6x. And when I divide by 6, I get x equals 12. In the next example, we see that C is equidistant from A and B. So C, because it was also perpendicular, is the perpendicular bisector here, which means that these are now equal. So I could set 5x minus 11 equal to 3x plus 17. So we could take away 3x from both sides. So we get 2x minus 11 equals 17. We can add 11 to both sides. So we get 2x equals 28. We could divide by 2, so we get x equals 14. And this one did want us to go a step further. They wanted to know how long the entire length of AB was. So I could put it into each of them and add it up, or put it into one of them and double it. And that's what I'm going to do. I'm going to do 3 times 14 plus 17. So that's 42 plus 17 is 59. And 2 times 59 will tell me that B is equal to 118. The next two are for you to try. Pause now if you'd like. The answers are posted on Google Classroom. Example 2, it says segment JK is formed by these points. Determine if L lies on the perpendicular bisector of JK. So if JK existed here, and I want to see if this point L is in fact on the perpendicular bisector, I'm checking to see if L was equidistant from the 2 points. So I'm going to find the length of JL and the length of KL, and I'm going to compare them to each other. If they're the same, then L is on the perpendicular bisector. If they're not, then it's not. So for JL, we're going to use our distance formula. If you recall, the distance formula was the difference in the x's squared plus the difference in the y's squared, all under a square root. So to do JL, I'm going to find the difference of the x's. So -7 minus -9 is like -7 plus 9. Difference of the y's, -8 minus 2. So this is going to be a 2 squared and a -10 squared. So that's 4 plus 100. That's the square root of 104. So we'll do the same thing for KL. So -9 minus 1 and 2 minus 4. Here we have -10 squared and -2 squared. That's going to be 100 plus 4. Remember, no negatives if you square a negative. And that's 104. So we do see that JL and KL are equal. So yes, since JL is equal to KL, L is equidistant, from J and K, and lies on the perpendicular bisector. So the next one that you're going to try is very similar. All right, pause now if you'd like. The answer is posted on Google Classroom. So we've talked about the perpendicular bisectors. Now we're going to talk about the angle bisectors. So angle bisectors are just anything that splits an angle in half, and we've talked about these before. Now, two things are going to be special when this happens. If a point is on the bisector of an angle, then that point is equidistant from the sides of the angle. So if D is on the angle bisector, then D to B and D to C are the same. And the reverse is true. If D is the same distance from both sides of the angle, then D has to be on the angle bisector. So we're still going to be setting things equal here. It's all about things being equal. So we have a angle bisector here because we see the two angles were split. So BD is the angle bisector of angle ABC, which would mean that AD and CD are the same. So we're going to set 13x minus 4 equal to 8x plus 11. Take away our 8x. So we have 5x minus 4 equals 11. Add our 4. So we have 5x equals 15. Divide by 5, and we get x is 3. And this one wanted us to go a step further and find the length of AD. I could put it into either because they're the same, but I may as well stick it into the one I see. 13 times 3 minus 4 is 39 minus 4. So AD is equal to 35. Here's one for you to try. You can pause now if you'd like. The answers are posted on Google Classroom. Example 4. I see that GI, or really, I see that I is equidistant from F and H. So then I is on the angle bisector of angle FGH. So these angles are equal. We're going to keep setting stuff equal. So 5x minus 37 is equal to 2x plus 20. Let's take away our 2x. So we have 3x minus 37 equals 20. We'll add 37. Nope, that's a 5. So 3x is equal to 57. We divide by 3, we get x is 19. And again, we're going a step further. They want the measure of FGH, the whole angle. So again, I could put it into one and double it, or put into each and add them up. I'm going to put it into one of them and double it. So that's 2 times 19 plus 20 is 38, plus 20 is 58. We're going to do 2 times 58, so that the measure of angle FGH is 116 degrees. So this is the final problem for you to try. Pause now if you'd like, but it is also the end of the video. That is the end of section 6.1.